So, the James Webb Space Telescope just detected a molecule in the atmosphere of a planet 120 light years away that on Earth is produced almost exclusively by living organisms. The molecule is called dimethyl sulfide, or DMS. On our planet, it is generated by marine phytoplankton, the microscopic organisms that float in enormous blooms across every ocean on Earth. When those organisms metabolize, one of the byproducts is DMS. It rises into the atmosphere and plays a role in cloud formation. If you have ever stood on a shoreline and smelled that distinct, salty, slightly sulfuric tang in the sea air, part of what you are smelling is dimethyl sulfide. It is one of the most reliable chemical indicators of active biology that planetary scientists know of. If you detect DMS in an atmosphere, and you have ruled out geological and photochemical sources, you are looking at a planet where something is alive. JWST found it in the atmosphere of an exoplanet called K2-18b, a sub-Neptune roughly 8.5 times the mass of Earth, sitting squarely in the habitable zone of its star, where temperatures would allow liquid water to exist on the surface or in an ocean beneath a hydrogen-rich atmosphere. The detection was made using transit spectroscopy, a technique where JWST watches the planet pass in front of its star and measures which wavelengths of starlight the atmosphere absorbs. Different molecules absorb different wavelengths. The DMS signature appeared at 3 sigma confidence. 3 sigma is not 5 sigma, which is the gold standard in physics for a confirmed discovery. But 3 sigma is far from nothing. 3 sigma means there is roughly a 1 in 700 chance that the signal is a statistical fluke. In any other context, that would be headline news. But the scientific community's response to this finding was not excitement. It was not celebration. It was a long, careful, institutional silence. Because confirming what that molecule implies means saying something out loud that most astronomers have spent their entire careers carefully, professionally, strategically avoiding. But that detection, as extraordinary as it is not the finding that should concern you. Because while JWST was scanning distant atmospheres for chemical traces of biology 120 light years away, a team of astronomers in Sweden was looking much closer to home. And what they found was not a molecule. It was over 100,000 metallic, reflective objects, captured in astronomical photographs taken between 1949 and 1957. Objects in orbit around Earth, before any human civilization had put a single thing in space. Not asteroids, not distant galaxies, not camera defects or radiation contamination, or atmospheric effects, or any of the explanations that would let everyone go home and stop thinking about what this means. The team tested every one of those alternatives. And when they were done, 349 of the objects passed every test for being exactly what they looked like. Real, physical, sunlight-reflecting objects in the gravitational vicinity of Earth. In the 1950s, before Sputnik, the lead researcher, a Swedish astronomer named Beatrice Villarol, did not hedge. In 2 papers released in October 2025, her team speculated openly that a significant number of these transients were metallic reflective objects in roughly geosynchronous orbits, likely of unknown origin. She used those words, unknown origin, published them. And then the scientific establishment did what the scientific establishment does when someone says something it is not ready to hear. It pushed back, hard. ArXiv, the platform where scientists publish papers for peer review before journal submission, rejected her work. The former head of the Pentagon's UAP investigation office publicly disagreed with her findings. A counterpaper was published attacking her methods, her data, and her conclusions. But Villarol did not back down. She published a response, and the fight is still happening. And here is the part that turned a fascinating astronomical puzzle into something much more unsettling. When Villarol cross-referenced her orbital transients with something completely unrelated, public UFO reports filed on the ground by ordinary people, the data showed a correlation. On days when people reported seeing unidentified objects in the sky, there was an 8.5% increase in the number of transients appearing in the star maps. The general public had no way of knowing what was on the photographic plates. The photographic plates had no way of knowing what people were reporting, and yet the 2 data sets lined up. Then she checked the data against nuclear weapons tests, and found that transients spiked by 45% the day after a detonation. Stay with me, because by the time this is over, you will understand why the most important evidence that we are not alone did not come from a telescope pointed at a distant star. It came from photographs of our own sky, taken 70 years ago, that nobody thought to look at until now. And you will understand why the scientific community is fighting over whether to accept what those photographs show. I am Graham Prescott, And if stories like this are what you come here for, subscribe right now because what follows is the most rigorous, data-driven case for non-human presence in Earth orbit that has ever been published. And the debate over it is still happening. Let me walk you through exactly what they found, step by step, because the rigor of the method is what makes this different from every UFO story you have ever heard. This is not a blurry photograph. This is not a witness account. This is not someone's uncle who saw something strange in the desert. This is data. 100,000 data points captured by one of the most important observatories in the history of astronomy, analyzed using statistical methods that any physicist can replicate. Villarreal's project is called VASCO, which stands for Vanishing and Appearing Sources during a century of observations. She and her team at a consortium of Swedish and international universities were originally interested in something entirely different: vanishing stars. Stars that had been documented in sky surveys in the 1950s, but that could no longer be found in modern observations. They used digitized copies of photographic plates taken by the Palomar Observatory in California, which has been surveying the sky since the 1920s, and compared them against modern data from surveys like Pan-STARRS. They found about 100 instances of vanishing stars, which is genuinely interesting in its own right, because stars do not normally just disappear. But that was not the discovery that changed everything. The discovery that changed everything was accidental. In one of the Palomar plates, Villarreal found 9 points of light that had suddenly appeared. They were not present on the plate taken 30 minutes earlier, and they were gone 6 days later. These brief flashes, which the team called transients, were difficult to explain. Villarreal published a paper in 2021 where she systematically ruled out the most likely explanations. They were not asteroids, which would have been moving and would appear as streaks rather than points. They were not distant galaxies, which would persist across multiple observations. They were not airplanes, which would also appear as streaks. They were not gamma-ray bursts, which have a very different optical signature. 2 explanations survived the filtering. The first was high-energy contamination of the photographic plates, specifically radiation from nuclear bomb tests. The Palomar Observatory in California is located not far from the former Nevada nuclear testing site, and radioactive contamination can produce spots on photographic emulsions. But there were no official atomic bomb tests conducted between 1949 and 1951, the period when this particular plate was exposed, so contamination was unlikely. The second surviving explanation was the one that changed the trajectory of Villarreal's career. The optical profile of these transients matched, almost exactly, what you would expect from a satellite glinting in sunlight. A metallic, reflective object in orbit, catching the sun at just the right angle to produce a brief, bright flash on a photographic plate. The match was clean. The profile was right. There was just one problem. The first human-made satellite, Sputnik, was launched by the Soviet Union in October 1957. This plate was from 1950, before Sputnik, 7 years before Sputnik. Whatever these objects were, they were not ours. In October 2025, Villarreal revealed that she had gone much deeper. 2 papers, released within days of each other, showed that the 9 transients from that single plate were not an isolated anomaly. Across nearly a decade of Palomar plates, from 1949 to 1957, her team had identified more than 100,000 transients exhibiting similar characteristics. 100,000. And this time, Villarreal was putting her cards on the table. Her team speculated that a significant number of these were metallic reflective objects in roughly geosynchronous orbits above Earth, likely of unknown origin. She did not say aliens, she said unknown origin. But everyone understood the implication. Finding one strange glint in an old photograph is a curiosity. Finding 100,000 of them, across 8 years of data, all behaving consistently, is a pattern, and patterns demand explanations. But a pattern alone is not proof. Patterns can be coincidences. Patterns can be artifacts of your data collection method. What Villarreal needed was a test. A way to prove that at least some of these transients were real, physical objects in the sky above Earth, rather than defects on the photographic plates or distant astrophysical phenomena or any other comfortable explanation. And the test she designed is what elevates this work from speculation to science. The logic is elegant, and I want you to understand it clearly because it is the backbone of everything that follows. If these transients were defects on the plates, scratches, dust, chemical imperfections in the photographic emulsion, then they would appear randomly across the entire sky. There would be no reason for defects to cluster in one region and avoid another. A scratch does not know where the Earth's shadow falls. A dust speck does not care about the geometry of sunlight. The same is true if they were distant galaxies or flaring stars or any other astrophysical phenomenon far from Earth. Distant objects do not care about Earth's shadow. They exist everywhere in the sky with no preference for one patch over another. But if these transients were reflective objects near Earth, objects glinting in sunlight the way a piece of metal catches the sun and flashes in your eyes, then they would vanish every time they pass through Earth's shadow, because in the shadow, there is no sunlight to reflect. The object is still there, still orbiting, still present, but it goes dark. It becomes invisible to the photographic plate, the way a mirror in a dark room stops flashing the moment you turn off the flashlight. If the bright spot on the wall was just a smudge, a defect, turning off the flashlight would not make it disappear. It would still be there in the dark, unchanged. But a real reflective object disappears when the light source is blocked. The Earth's shadow is the flashlight being turned off. And if these transients were real reflective objects, they should show a measurable deficit in the region of sky where the shadow falls. Villarreal ran the statistics across all of her transients, and the result was unambiguous. There was a significant measurable reduction in the number of transients within the region of sky corresponding to Earth's shadow, at an altitude of approximately 42,000 kilometers. In her response to later criticism, Villarreal reported this deficit at approximately 7.6 sigma significance when the survey's sky coverage was properly accounted for. 7.6 sigma. For context, the discovery of the Higgs boson was announced at 5 sigma. This is a strong statistical result. It does not prove the objects are alien. It proves that a meaningful subset of the transients behave exactly as sunlight-reflecting objects near Earth would behave, and exactly unlike plate defects or distant stars would behave. 349 specific transients passed this test. Background noise does not vanish in the Earth's shadow. Plate defects do not vanish in the Earth's shadow. Distant stars do not vanish in the Earth's shadow. Reflective objects in orbit around Earth do. So the shadow test established that at least some of these transients were physical objects reflecting sunlight near Earth. That alone would be extraordinary enough to warrant serious investigation. But Villarreal was not done, because she had a second data set to check her transients against. And the results of that check are what made the scientific community genuinely uncomfortable. She cross-referenced the timing of transient appearances with public UFO and UAP reports filed by ordinary citizens on the ground. These are two completely independent data sets. The people filing UAP reports had no access to the Palomar photographic plates and no knowledge of what was being captured on them. The photographic plates had no awareness of what people on the ground were seeing or reporting. And yet, on days when more UFO reports were filed, the number of transients in the star maps increased by 8.5%. Each additional report on the ground correlated with more objects appearing in space. The correlation held across the full data set. Then Villarreal checked the transient data against the schedule of nuclear weapons tests conducted during the same period. And the results escalated the story to an entirely different level. There was a 45% uptick in the number of transients appearing the day after a nuclear detonation. The transients were not appearing during the tests themselves. They were appearing afterward, as though something had noticed the detonation and moved closer to observe. Now, this correlation was later revised downward when Villarreal accounted for the fact that the Palomar Observatory was 35% more likely to be conducting observations during nuclear test windows, a scheduling artifact created by the observatory's operations calendar that inflated the apparent connection between transients and tests. After the correction, the uptick was approximately 11%, smaller but still statistically present at roughly 3 sigma. Which in statistical terms means there is less than a 1 in 300 chance the correlation is random. This matters because the link between unidentified aerial phenomena and nuclear weapons is not new. It has been discussed within the UAP research community for decades, supported by eyewitness testimony and military records, but always anecdotally, never with hard statistical data. The anecdotal cases are themselves remarkable. In October 2010, a cigar-shaped object was reportedly seen by multiple groups of Air Force servicemen above F.E. Warren Air Force Base in Wyoming, a facility that housed 50 Minuteman III intercontinental ballistic missiles armed with nuclear warheads. During the sighting, all 50 missiles simultaneously went offline. Their launch systems entered an error state that had never been seen before at that scale. Individual missile malfunctions had occurred in the past, small numbers going temporarily offline due to software or hardware faults. But 50 at once was unprecedented. It represented a severe breach in national security. The missile dropout is a documented fact. It appears in Air Force records. Whether the cigar-shaped object caused it is a matter of interpretation. but the temporal coincidence is difficult to ignore. In Soviet records from 1982, a UAP allegedly hovered above a nuclear missile base for 4 hours, after which intercontinental ballistic missiles reportedly activated on their own and began a launch sequence that ground controllers could not override. The missiles could not be shut down until the object departed. Only then did normal control resume. If these accounts are accurate, they suggest not just observation, but active interaction with nuclear weapon systems, and an ability to both disable and enable those systems remotely. All of this to say, it is one thing to hear stories like these from military witnesses. It is another thing entirely to see a statistical correlation emerge independently from photographic plates taken by an astronomical observatory. Villarreal's data is the first time hard numbers have been used to establish a link between unidentified orbital objects and nuclear weapons testing. The anecdotal stories existed for decades. Now there are numbers to go with them. And all of this, every transient, every correlation, every statistical test, was captured on photographic plates taken before Sputnik, before any human satellite existed, before the space age began. Now, you would think that findings this significant, backed by this much data, would be received by the scientific community with open arms, or at least with serious engagement. That is not what happened. Villarreal submitted her papers to EREXIV, the standard platform where physicists and astronomers publish preprints for community review before formal journal submission. EREXIV rejected them. The moderators deemed the work not sufficiently original or containing enough substantive scholarly research. This is unusual. EREXIV accepts an enormous range of papers. Its threshold for inclusion is generally low. The rejection was a signal, and Villarreal took it as one. Sean Kirkpatrick, the former head of AARO, the Pentagon's All-Domain Anomaly Resolution Office, which is the U.S. government's official body for investigating UAP, publicly stated that he did not agree with the findings. He suggested that the transients could be explained by solar flares or high-altitude balloons, but he did not publish a paper to support that suggestion. He disagreed without showing his work. The ones who did show their work were Wesley Andre Waters and his team, who published a counterpaper with the title Critical Evaluation of Studies Alleging Evidence for Technosignatures in the POSC-1E Photographic Plates. The paper was detailed, methodical, and pointed, and it attacked Villarreal's work on multiple fronts simultaneously. First, they argued that the proper way to determine whether transients were real objects or plate defects was to examine the original physical photographic plates under a microscope, not the digitized versions Villarreal used. The distinction matters. When a photographic plate is digitized, the scanning process can introduce artifacts, dust on the scanner, optical imperfections in the scanning lens. Even the resolution of the digitization itself can create or alter features in the resulting image. Under a microscope, examining the actual physical emulsion, it would be immediately clear whether a given transient was damage to the photographic coating, a speck of contamination embedded in the surface, or a genuine captured image of light that passed through the telescope's optics and struck the plate during the exposure. Villarreal had not done this physical examination. Second, Waters questioned Villarreal's dataset itself. When his team attempted to replicate her sample from the available data using what they considered scientifically appropriate vetting criteria, they argued that she had used a broader, less filtered pool of objects than was justified. Many of the transients in her sample, Waters claimed, were likely plate defects, scanning artifacts, or known astrophysical sources that had been insufficiently screened out. When Waters applied his own stricter vetting process, removing everything he considered insufficiently validated, the number of transients dropped from approximately 100,000 to just over 5,000. And with that smaller vetted sample, the statistical drop in Earth's shadow disappeared entirely. If the shadow effect vanishes, the entire case for reflective objects near Earth collapses. No shadow effect means no reason to believe the transients are near Earth rather than being randomly distributed noise. Third, they pointed out the Palomar scheduling issue, the 35% higher likelihood of observations during nuclear test windows, and argued that Villarreal had not sufficiently accounted for this in her original analysis, making the nuclear correlation an artifact of uneven observational sampling rather than a genuine signal from the sky. Villarreal responded. Her response paper, which EREXIV did publish this time, was methodical, thorough, and at times openly combative. She went through Waters' arguments point by point. On the question of her dataset, she argued that Waters' more vetted sample was actually over-vetted. By applying excessively strict filtering criteria, he had systematically deleted the very objects she was looking for. Transients, by their nature, are brief, faint, and easy to filter out if your criteria are tuned to preserve only long-lasting, well-documented objects. Reducing the sample from 100,000 to 5,000 eliminated 95% of her data, and she argued that a sample of 5,000 was simply too small to produce statistically meaningful results for the kind of analysis she was performing. The shadow test requires a large enough sample to detect a subtle density variation across a large area of sky. With 5,000 transients spread across 8 years of plates, the signal disappears not because it was never there, but because there are not enough data points remaining to resolve it. On the Earth shadow deficit itself, Villarreal stood firm. She reported that when the survey's sky coverage was properly accounted for, accounting for the fact that the Palomar plates did not cover the entire sky uniformly, the deficit of transients within Earth's shadow was significant at approximately 7.6 sigma. She argued that Waters had not applied this correction. She reran the nuclear correlation with the corrected Palomar scheduling ratio, accounting for the 35% observational bias, and still found an 11% uptick in transients during nuclear test windows. Smaller than the original 45%, but still there, still statistically present, still requiring an explanation. And in what became the most quoted line from the entire exchange, she noted that if Waters had wanted to know exactly which dataset she was using, which specific filters she had applied, which plates she had included and excluded, all he needed to do was send her an email. She would have shared it. He did not ask. This is how science actually works. Not as a smooth, dignified march toward truth, but as an extended, public, occasionally petty argument where both sides have data and neither side is willing to back down. The papers are the punches. The citations are the bruises. And the truth is somewhere in the middle of the fight, waiting for one side's data to finally hold up under every attack the other side can mount. So where does this leave us? The data is not settled. The debate is live. Villarreal and Waters are still publishing. The scientific community has not reached consensus. But there are facts in this story that nobody disputes, and those facts are worth stating clearly. Nobody disputes that over 100,000 transients exist in the Palomar plates. They are there. They are visible. They can be counted. Nobody disputes that some of them behave differently in Earth's shadow. The degree of the effect is debated. The methodology for measuring it is debated. But the existence of a measurable difference in transient density between shadowed and unshadowed regions has been observed by multiple analyses. Nobody disputes that the plates were taken between 1949 and 1957, before Sputnik, before any human-made object had ever reached orbit. That is a matter of historical record. Nobody disputes that the optical profile of a subset of these transients matches what you would expect from reflective objects near Earth rather than plate defects, which tend to have different morphological characteristics under careful examination. And nobody disputes that Villarreal's work has been published in peer-reviewed scientific journals, not just on preprint servers, which means it has passed at least some level of formal scientific scrutiny. The question is no longer whether there is evidence. There is evidence. It has been published, reviewed, criticized, defended, and reanalyzed. The question is whether the evidence is strong enough to support the extraordinary conclusion it points toward. And that question is being fought over right now by people whose entire careers depend on the answer. And there is one more fact that gives this entire story its urgency, a fact that should concern anyone who cares about scientific inquiry, regardless of where they stand on the question of whether these transients are alien technology. We cannot repeat this observation today. The sky above Earth is now filled with thousands upon thousands of human-made satellites, each one producing exactly the kind of sunlight glints that Villarreal found in the old plates. SpaceX alone has launched thousands of Starlink satellites. Add in the satellites of every other nation and corporation, the spent rocket stages, the fragments of debris, and the sky is a kaleidoscope of human-made reflections. If non-human objects are still up there, orbiting alongside our own hardware, we would never be able to distinguish them from the noise. The only clean window to have detected them, the only period in the entire history of human civilization when the sky above Earth was free of human-made reflective debris, was 1949 to 1957. 8 years. That is it. Villarreal found them in exactly that window. And now the window is permanently closed. And that brings us back to James Webb. JWST is looking for biosignatures, chemical traces of life, on planets orbiting distant stars. It found dimethyl sulfide on K218b at 3 sigma confidence. That is a detection that says something might be alive on a planet 120 light-years from here, producing the same molecule that phytoplankton produce in Earth's oceans. VASCO is looking for technosignatures, physical evidence of technology, not on a distant exoplanet, but in our own backyard, in photographs of our own sky taken by our own observatory 70 years ago. It found a shadow deficit at 7.6 sigma confidence, a statistical result that says something reflective was orbiting Earth before humans had the ability to put anything in orbit. Both projects are asking the same fundamental question: are we alone? JWST asks it through chemistry, analyzing the composition of faraway atmospheres molecule by molecule. VASCO asks it through physics, analyzing the behavior of light sources in archival photographic plates data point by data point. Both have evidence, neither has proof. And both are facing the same institutional reluctance to engage fully with what the data suggests. The dimethyl sulfide finding is described as suggestive. The Earth shadow deficit is described as contested. The language is careful, the hedging is deliberate, and the caution is real. But consider the irony: the JWST detection, the one that gets the headlines and the careful scientific attention, is at 3 sigma confidence. The VASCO finding, the one that got rejected by ArcSiv and dismissed by the former head of the Pentagon's UAP office, is at 7.6 sigma. The higher confidence result is the one closer to home, and it is also the one the scientific community is less willing to engage with. That asymmetry is not about the data, it is about the implications. Finding a molecule that might indicate microbial life on a planet 120 light-years away is scientifically thrilling, but personally unthreatening. It does not change your daily life. It does not challenge your assumption that the sky above your house is empty. Finding metallic objects in orbit around Earth before the space age is a different kind of finding entirely. It is immediate, it is local, and if it is real, it means something was here, watching, before we even knew to look up. The reason for the caution is not scientific rigor. The reason is fear, because being wrong about this specific question, in either direction, is career-ending for a working scientist. If you claim evidence of life and you are wrong, you are a cautionary tale. If you dismiss evidence of life and you are wrong, you are the person who had the answer and threw it away. Both outcomes are terrifying for a working scientist. And so the safer path is silence, caution, hedging, more data needed. But if these transients are real, and if we chose not to investigate because we were afraid of the answer, that is not scientific caution. That is something else entirely. The plates are still in the Palomar archive. The original photographic emulsions still exist. They could be examined under a microscope by an independent team with no stake in the outcome. The data Villarreal identified could be verified or dismissed with physical examination of the original materials. 70 years of evidence, captured before Sputnik, is sitting in a building in California, waiting for someone willing to look. We have spent decades pointing telescopes at distant stars, hoping to find signs that we are not alone in the universe. JWST found a molecule. VASCO found reflections. Both could be nothing. Both could be everything. Humanity has a long history of seeing strange things in the sky and assigning them supernatural causes. The lights over Nuremberg in 1561 were attributed to the displeasure of God, a warning to the people to repent their sins. The newspaper account describes spheres, crescents, rods, and a large black spear appearing over the city and fighting among themselves before falling to the ground in flames. To a modern eye, the description sounds eerily like an aerial engagement between artificial craft. To a 16th century eye, it was a sign from heaven. Lightning was the anger of Zeus, comets were omens of doom, eclipses were cosmic punishments. As we learned more about the world around us, the supernatural explanations gave way to natural ones. Lightning became electricity. Comets became ice and rock orbiting the sun on long elliptical paths. Eclipses became the predictable geometry of a moon passing between a planet and its star. We got smarter. We found the real explanations. And that process, the process of replacing superstition with understanding, is one of the greatest achievements of our species. The instinct to seek the natural explanation first is correct. Extraordinary claims require extraordinary evidence, and most of the time the ordinary explanation wins. But the opposite error is equally dangerous and considerably less discussed: seeing real evidence and dismissing it because the implications are too uncomfortable, requiring a higher standard of proof for findings that challenge our assumptions than for findings that confirm them. Treating a 7.6 sigma result as less credible than a 3 sigma result because the 7.6 sigma result implies something we are not ready to accept. That is not skepticism. That is denial wearing a lab coat. And it has happened before in the history of science, with plate tectonics, with heliocentrism, with the germ theory of disease, with every paradigm shift that required the scientific establishment to admit it had been wrong about something fundamental. 120 light-years away, a molecule is glowing in an atmosphere that should not contain it. It was detected by the most powerful space telescope ever built, and the scientific community is proceeding with appropriate caution because the detection is at 3 sigma, and more observations are needed to reach 5. 70 years ago, something was glinting in a sky that should have been empty. It was captured on photographic plates at one of the world's premier observatories, and the statistical analysis of those glints has produced a 7.6 sigma deficit in Earth's shadow that nobody has successfully explained away. Both of these are facts. What they mean, individually and together, is the question we have been afraid to ask since we first looked up at a night sky full of stars and wondered whether, somewhere out there, something was looking back. And for the first time in the history of that question, the data is starting to answer. If this kind of story is what you come here for, subscribe right now and turn on notifications because next time we are going deeper into what JWST's K2-18b data actually shows at the molecular level. And the details are wilder than the headline. Drop a comment with where you stand. Are the Villarreal transients evidence of something in orbit before Sputnik? Or is there an explanation we are missing? Because the scientists are still fighting about it, and your guess is as good as theirs right now. And share this with someone who needs to hear it because this is not a UFO